So we welcome you very, very much to the first public AvaFrame workshop. This is the core development team of AvaFrame, which is Felix Oesterle, Anna Wirbel, Matthias Tonell, and myself. Felix is the one that's going to guide you through the introduction today and tell you a little bit about what AvaFrame is. And then we're going to go into an interactive part where you actually can work yourself for the first time with AvaFrame. To do so, you're going to need the data you find on the webpage of AvaFrame, avaframe.org, the Open Avalanche Framework. It's there in the recent posts, or it is here in the chat. And in the chat, you can also download. So you get the data there or on the homepage. Welcome to the last couple of people that arrived. You didn't miss anything. I was just explaining that in the first part, we're going to do an introduction on a couple of slides, and then we're going to have an interactive part where you're going to need the data that you find in the chat or that you find on the homepage. So far, this would be the first thing to do for you guys. Before we start, we would like to ask you a question. Is actually, I have to share the results first because I need to restart the poll. Felix, can you restart the poll? Relaunch, here it is. And the poll should be running right now. The question is about your background, because we also want to learn a little bit about you, what your background is, and later on, we're also going to ask you how you want to use AvaFrame. So AvaFrame is supposed to be a tool that is for operational use. So engineering applications, hazard mapping, and actually stuff to work with. The second goal of AvaFrame is that it is educational. So for example, at universities or something, you can use it to teach your students or explain them how avalanche models work. And I on purpose say avalanche models because we are not only talking about one particular class. This is what Felix is going to show you. There's a lot of classes already living in AvaFrame. And the third big part should be research, which is also the development, where we warmly would welcome you to contribute in developing AvaFrame. I'm going to share the results right now with you. So most of you come from operational background, some people from the educational one, and half. So one half is research and education, the other half is operation. And this fits also in our main purpose of AvaFrame and where the project was born. But Felix is going to tell you more about this. Felix, I hand over the word to you.
All right, thank you for your introduction. So let me start, and I'm going to go right in. So we have this AvaFrame project, and of course, every project needs a goal. And we have our mission statement, and I'm going to just read it, which is to develop an open source framework for avalanche simulations. And this is the important part, which replicates and simplifies current procedures and models at the Austrian torrent and avalanche control. I go into this in a little bit more detail soon. So what are the goals? Why are we even doing this? So first of all, we want to have better code availability, so open source, and we want to be able to maintain it a little bit better. We want to transfer current developments to operational versions, of course. I mean, the aim is to support operational ideas. And as JT already said, we have these three use cases of operational, scientific, and educational use. And again, it should be multi-domain and multi-model, not only one type of model. And we go into detail a little bit later on. So the background itself is, so who's funding it and who's working on it? It's a cooperation between the Austrian Avalanche and Torrent Service and the BFW, the Austrian Research Center for Forest. So basically the Austrian Avalanche and Torrent Service is funding it, and the BFW is executing it in a cooperation. We have our core team, but there's also more. There are more people involved than just the core team, and I'm putting some main important names on here. There are a lot more people than this, but so that you know which people are involved. We have a steering committee overseeing that the project is running fine, which the head is Florian Rudolf Miklau. We have a project coordinator, which is Gebhard Walter from the Austrian Avalanche and Torrent Service. And then we have a scientific committee, and there the head is Ingrid Reiweger from the BOKU. The idea behind those committees is to support the AvaFrame project and make sure that the aims and the directions we take are the right ones. And then another very important team is the operational team at the Avalanche Torrent Service. They are people that work in daily operational applications, and they help us to test the model, make sure it gives the right results or it does the right things for the right reason. And then we have the core team. As JT already said, there are two leaders, which is myself as the project team lead and JT as the scientific lead working on this. We have two more people working full-time on it. One of them is Anna Wilbel. You're going to see her more often in here as well. She's working with the numerics, does mainly the process modeling and the tests and verification. And we have Matthias Tonel, our French guy, working on numerics again, optimizing and code tests. So he comes from the mathematical side of things. And these are, let's put it this way, the tasks we put to people is the main focus, but of course we work together. And if you contact us, we will send you to the right person that can answer your question if you have some. Now, what is the structure of the framework? Because this is a main part, it being a framework. So we have AvaFrame, and then I put on purpose, I put the GUI.js script in GUI on the outside of this, because the idea behind AvaFrame itself is to have those base functions and not be too concerned about how you control it. Of course, we provide connectors to GUI.js, but the main work we work on are modules that live inside scripts and such. And the idea behind AvaFrame is that you have multiple models you can use, or multiple modules, support modules, let's say on the input side of things, where you get data in, you do path modifications, you do parameter variations. And then you have your main models. I'll come to the name a little bit later on, which is COM1 DFA, COM2 AB, and there could be a host of other models that could live in here. These are I would say, the main core modules which do the main computation of avalanche simulations. And then, of course, you have to have other support modules around, like plotting, like doing statistical analysis, returning results again back to the QGIS world, or a host of things. And overarching all, of course, you want to make the whole process reproducible. So you need to do reporting, logging, and getting information about what you did 5 years ago might be really important. And this is the entirety of the AvaFrame framework. But of course, we talk about the operational application today a lot. So what the idea behind this is that you have this one path, and it's shown here in red, which basically gives you a fixed set with a standard setup that is being used in current operations in Austria. And this is the one where we make sure that it's always stable, that you get consistent results, and so on and so forth. Whereas in the other modules, there might be a lot of development going on. And I mean, because a lot of you come from engineering offices, we have to clarify something about how does COM1 DFA, which is our main dense flow avalanche module, compares to Samos.at. So Samos.at, for those who don't know about it, is being developed and in operation use since about plus 20 years now. It provides tools to run dense flow avalanches and powder snow avalanches. And a little offspring of this is Samos Beta, which contains the dense flow avalanche standard setup. And now if you look at our modules, you will see one that is called COM1 DFA original. This is basically the dense flow kernel from Samos.at as a standalone version. So we took the C code, so we got the C code from Samos.at, and we have the code available, but we only publish the executable. It is available on our homepage, but let it be known that it will be phased out soon. And now we took this dense flow kernel and converted it to a Python Cython version. And this one is now fully open source. So when I talk about COM1 DFA, this now is the kernel, which was original, the standalone DFA kernel of Samos.at in a different language. So it's not, as you can expect, it's not 100% the same, but it's as close as possible. Because this was the requirement for us for the version 1.0, that the results of this COM1 DFA and SamosAT or / COM1 DFA ORIC, they should be as close as possible. We won't be able to do a 100% fit, but as close as possible. And the current status that we have is that we have a release candidate for the version 1.0 out. And with the final version of 1.0, we will also publish the different support where we show how we investigated or made sure that our version and SamosAT COM1 DFA ORIC version are as close as possible. This will be then published on our homepage. And this leads me to the thing that I want to show next. Which resources will you have available for you if you try to give it a go? So let's head over to our browser, and I hope everyone sees this. The first one to start off is our homepage. There you will find a lot of information. You will see that we give monthly updates of what's going on. This might be interesting if you want to see what went on. But you will also find links to other important stuff, namely documentation and the code itself. What am I talking about when I talk about documentation? If you go to the documentation, you will be greeted with a picture like this. And this is where we collect everything. And yes, it is a lot out there, but it tries to cover a lot of different things. First of all, one of the most important one I would say is this installation and first run. If you already gave it a try, when you try to install it, you will be familiar with it. I will cover the different types of installations later on. But apart from that, you will also find other information. For example, more information on the modules themselves. This usually includes some chapter about input, model configuration, how you can configure things, or how to run it. And if you want to go into the full depth, then you can also look at theory, where we try to list all the theory that's behind it, theory-wise and numerics-wise. This is the information that you have there. If you want to then later on, for those people that work in research and education, if you want to dig deeper, you can also look at, we have an API reference. You can go through and see which functions that we provide overall. You can click through it, and then if you go to certain functions, you will get the information about what is needed as input, what you get as an output, and so on and so forth. This is the information that might be interesting for you. And then last but not least, where does our code live? Our code lives on GitHub, so that's where you can have a look at it. This is also the spot where you should go to if you want to report some issues. So we're happy to get issue reports from you if you have any troubles or problems. This is where you find the latest development code and so on and so forth. So these are the main informations that you can get for yourself. And then last but not least, how do we communicate? I mean, of course, if you know our emails is fine, but we also are running a Matrix server, which is, if people are familiar with Slack or Teams, something similar. We have a small introduction on how to do this on our contacts page if you're unfamiliar with Matrix element. But this is the way, if you want to get into discussions with us, it's often the easiest because we can include people that might be able to help you more easily. Okay, I was talking about installations. Now let's go over the standard ones. So the one that we are talking about today is the standard or / operational one. This is the one that you should use if you want to use it for hazard mapping or some other similar stuff. This is the well-calibrated setup, and it's going to be the stable one. You're going to use QGIS as a front end, and this is also always going to be the latest stable release, which also means you will only be able to do minimal parameter adjustments. I'm going to go into these later. And then there's the experiment education one. This already requires programming. You can build your own workflow by adjusting the configuration itself. but it does not work fully at the moment. You can make your way around it, but it's not clear. But we will put this up soon. And then there's the last one, which is the develop installation. This is the one you can use if you want to work on code itself, or if you want to implement features. And this is always going to be the latest development code. So it might be unstable and things might break. So be aware of that, which we will announce, but you can't say that. And this also brings me to a point that is important for AvaFrame, I think, is so AvaFrame is absolutely open to your contributions. So this might be new features, it might be helpers and tools, or you want to change something or add something. This might be investigation into topics that you think are interesting and should be looked at it more closely. And so we are very welcoming your contributions as well. And some information or some publication about this will be on the EGU in 22, the International Mountain Conference. And of course, we will also offer more workshops in the future. And we will always do this via our homepage. And then is a very important point. Let's talk about the license. So what does this mean? AvaFrame itself is open source, but it's licensed under the European Public License 1.2. If you use this link, you will find the full text of this license, and the license is available in 21 languages, so you should be able to find the one that suits you. The permissions you have, you can use AvaFrame for commercial use. You can use it in private use without telling anyone. You can do modifications to it, but with a few conditions and limitations. Let's go to the conditions first. So you also, if you do changes, you have to disclose the source. You have to put up a license and copyright notice. And this is important. Your changes will also be the same license. And you have to state changes. And then there's also limitations. So there is no liability or warranty from the AvaFrame project included in this license. And if I want to put the whole thing very bluntly, basically do what you want, but if you F it up, then it's your own responsibility. This is basically it. Okay, and with this, I'm going to go over to the operational workflow of QGIS. The operational workflow of QGIS includes, at the moment, 2 modules. One is the COM1 DFA, so this is dense flow avalanche information, and then the second one is the COM2AB, the alpha beta statistical model that's in there. What do we need? We need a DEM. As such, the COM1 DFA runs on a 5-meter grid, but you can provide any resolution, but it will be remeshed in both directions. So if you have a higher resolution or lower resolution, it will be remeshed to 5. Furthermore, you will also need a profile and a split point. I'll go into this when I show it to you. And then, of course, you need release areas. So you can provide either one area or multiple areas. I'll show this as well. And optional, you can provide entrainment areas or resistance areas. What are the requirements for the inputs? So first, let's talk about a very important point, especially when you're working with QGIS, the projection. Any projection is fine as long as all data is in the same projection. And here's an important caveat, because this is something that happens quite often. It has to be in the same projection and not being reprojected on the fly, because in QGIS you can load in data and assign a projection, and then it will reproject on the fly. And if you do this, AvaFrame will not work because the data itself is not the same projection. The DEM has an ASCII format, but you will see that this is being handled by QGIS anyway and defaults to 5 meters, as already mentioned. And then we have the release areas. This should be shapefiles, and they have an attribute thickness and should have an attribute thickness and name in it. And the thickness sets the release height at the beginning of the simulation. And you can have one shapefile per scenario. So what do we call scenarios? You can cluster multiple release areas if you want to, and say this is one scenario, and then they will all be started at the same time. And you can have multiple scenarios run at the same time. I will show that as well. And then the same goes for the entrainment and the resistance, but here it's only one shapefile where all the entrainment areas are in, and one shapefile for all the resistance areas. Okay. Are there questions so far? If
So
not, yeah.
Felix took you already deeply in technical avalanche simulation language. Maybe for those who are not deeply in it, they will get a look now when we go into QGIS, which is Felix preparing right now. But to also just arrange or like put AvaFrame into the context of existing avalanche simulation tools, which we all have. Everybody knows RAMS. Some people or a lot of people also know Samosate. There's nowadays a lot of open source solutions like AvaFlow. There's there's very open solutions like OpenFOAM where you need to develop your special own models. There's the Titan 2D from North America. There's the Trend 2D from Italy. Then we have some French models. We have Norwegian approaches. So why do we need this? Just to maybe also put AvaFrame in a larger perspective. The idea behind it is to not develop the one new model, but develop a framework where a lot of models also can talk to each other. Like as Felix already showed, there's a lot of modules that not necessarily do avalanche simulations, but they have the purpose of testing, of comparing. Like the whole framework can be adapted to use different computation modules, and also talking about modules, avalanche simulation. It's always about we have a release, we want to compute where it goes, and we see where it ends up. And there's a lot of different models. Felix already named the alpha beta model, which operates on a terrain profile. Samosate, like RAMS, operate in three-dimensional terrain, which we also do here, like all the other shallow water models. And in this world, I think Felix now going to take us in two examples. One is shallow water modeling with the common DFA model, and the other one is modeling or simulating a long avalanche path profile with implementation of the alpha beta model.
Okay. Yeah, I'm going to take over here. So if you downloaded the data that we provided and loaded into QGIS, you will be greeted with something like this. Let's quickly go through what we have here. So first of all, we have our topography. This is, again, just the STDM data in 5 meters in this case. I just put in the contours so that it's a bit easier to see for you. We have one entrainment area. We have a path. Oh, hold on, this is really hard to see. Let's make this bigger. We have a path which tries to hit the main path of the avalanche and is longer than the avalanche it's going to run. This is then being used for analysis and for the alpha beta simulation. We have one important point which we can't get rid of yet, which is the split point. This split point defines that as is being the point which below which you are looking for the 10-degree point. Because for alpha beta, the 10-degree point is an important one. And sometimes you have areas higher up in the avalanche which are already below 10 degree, and it's sometimes not that easy to find or consistent to be found. So you can use a split point to force the point to be below this point. And then what we have here are release areas. This is one, and then I just made a second one, which is basically a smaller version of the first one. Now, when we look at this information that's being given here in this shapefile, you can see that we have different attributes in this or the shapefile, and one of the important one is first of all the name, which is being used in naming of output and so on, and then second of all is the thickness, which is now set to 1 meter, so it's basically the relief thickness up there, and you can set this per shapefile as you want it to be. So in this case of the other scenario, I have a thickness of 1.4 meters. And I have a different naming, of course, which is important later on for naming of the output files. And if you did everything correctly, you will find AvaFrame. So just for those who didn't do it, to install AvaFrame itself, you have to do a two-step process. First of all, you have to manage and install plugin and install the AvaFrame connector. And then you have to install the Python libraries in the terminal. But the installation itself is described on our documentation, if you want me to say so. And if you did everything correctly, you will get an AvaFrame connector. And this is the one that is being used for you to run your scenarios. And early on, I said something about that you have only minimal adjustments regarding the parameters of the model itself. In this case of the operational workflow, we say we provide this standard setup that is being set up for Austrian use, and is the standard setup being used at the Austrian Avalanche and Torrent service. And the things you can change are basically the thickness of the release and the release area, release size. Everything else is being done by the model itself. So very similar to those people who are familiar with it, very similar to Samos Beta. And if you look at the AvaFrame connector, this is how you start it. First of all, you need to choose the DEM. Of course, it's we have only one. And then you can select release layers. And this is where you can now do different scenarios. So if you have multiple scenarios and you want to run them at the same time, you can find them here, and you can just activate them independently here. Whichever ones, other ones that you want. I'm going to start with only one for it to be run a little bit faster. So you choose the release area, and then you have to choose a profile layer, which in my case is the path AB, and you have to choose a split point layer. And this is all that you need to set, apart from the output folder, which I'm going to save to a directory. So choose this one. This is all that's the minimal that you have to provide. If you provide entrainment or resistant layer as well, you can do this here. And this is something to note. If you provide entrainment and resistance layer, you will always get the simulations without entrainment and resistance, which we call null simulations as well. But in this case, I'm just going to do this one, and then you click on run, and if everything goes fine, you can see it's doing something. If you want to know a little bit more what's going on, you can click on plugins and enable the Python console, and then you will get information feedback about which time step you are being on. And this is going to take a little while. It already gives you info about the input parameters. It gives you information about where your DEM comes from, and so on and so forth. And if we wait a little while, I think it runs to 170 seconds. You will see that we will get the results fed back to the QGIS right away, and should be there any minute. So. Takes a little while, and then you will get informations. First of all, one very important information is for you, in case you didn't remember where you put the output folder. You will get the information where this is located, and then you see how long it takes. I mean, this is something purely out of interest, and then you see the information that was fed back. So let's close it, and let's have a look at what we got as a return. So I'm gonna turn off a few results to go through. So first of all, you will get information. Let's see. Unfortunately, we cannot set this automatically as of yet because of a QGIS bug. So you will get alpha beta informations. You will get different runouts, different angles, let's put it this way. So you will get the beta point where this one was found. You will see where the main alpha is, and then this thing where we add and subtract standard deviations to this alpha point. This is one result that you get. I will show you later on that we also have a report where you can see pictures. And then another very important stuff is the one that I'm most interested in is the peak flow variables. You have three: peak pressure, peak velocity, peak flow velocity, and peak flow depth. And they are all already set with a legend. If you want to change this, it's up to you. We provide this legend. The values are there. So you get the peak flow velocity, for example, over the whole simulation. And you also get the peak flow depth as such. And now comes the point. This is all the feedback you have in QGIS. You have those main fields as a feedback. But if we go into this directory, of course I have to misclick. You will find that you have this output AvaFrame folder. And in this folder now, you have a lot of different things. First of all, something that we might ask if we try to help you with a bug or something is the log itself. So the log itself is something that where everything is being logged of what's being done. So it starts with giving you information about when it was started, the AvaFrame version. It might be very interesting. And then you see a bunch of stuff about how the model itself was set up and what was being done, what was being run. So a typical log information, which might or might not be of interest for you, and also some results. You will also find in here the inputs. So if you run it from QGIS and you have it saved somewhere else, it will collect all the inputs to this folder. And there you find, for example, the topography again, you find the release areas and lines and so on and so forth in case you want to redo this simulation again. The work folder is something that is just a temporary, so usually there's nothing in there that you want. And then we have this output. And the output itself, again, is being split in different modules. First of all, you have a report, which might be very interesting to you. And you can open this. This is a markdown file. You can open this with different things. What I usually tend to do is I open it with Chromium and have a it opened up. And the report itself, again, is something which gives you a quick overview of what was being done. So you'll see that you have a simulation name, you have parameter, the main parameter informations. You have information about the release area, and then just some pictures. So this is to get a quick overview, or if you want to document what you did, this is a good way to do it. You get the results from the COM2 AB simulation, the parameters that went into it, and the results that came out of it, and you get this plot where you can get information about it. This is something that you can add to one of your reports if you need to. And then what you also have in here are those pictures. And this is from the report, but in the output itself, you have outputs from these two modules. And for example, in the COM1 DFA, you will find, for example, the peak files. If you want to visualize them somewhere else, this is here where you have the ASCII information about different peak files themselves. And by default, it also writes out peak files at certain time steps in case you are interested in those as well. But usually you won't need it. And in here are a bunch of other stuff like the configuration files and so forth. So if you give this folder, this whole output folder to someone who doesn't have your version of AvaFrame, it is possible to completely replicate whatever you did. Okay. This is it from my side regarding the introduction of how you run things. I guess now we can open the floor for questions.
Thank you, Felix, very much for introducing this in half an hour, pretty much. So how to get your first simulation done in AvaFrame. And again, a little bit like maybe translating terms that we go technical on right away is for sure all the QGIS standard terms, like all the shapefiles and something like this. So people here should be familiar with all the GIS language, I think. And maybe just to again explain the terms that we use in our computational modules, which is the COM1 DFA, DFA as the dense flow avalanche. So this is the classical shallow water model, Graham-Samos, and the COM1, COM2AB, which is the alpha beta model, which goes along the profile. And there have been already a couple of questions in the chat, which were about if you can run these modules independently. You can, in general, do way more than Felix just showed. Felix just showed you the easiest and simplest way to get your first simulations done through QGIS. All of this can be done in a very variable way if you use script language and use Python and tell the model exactly what you want to do. At the moment, the standard run includes both the alpha beta model and the shallow water, the dense flow avalanche model. So automatically both are run. In principle, it's no problem to change this. Again, the things we show here today is our very first step of something that we can show and where we are confident with you can use this model, but there's a lot of room for improvement, and this is also why we have you here, because we would very much appreciate your feedback and see where we should go with the development. Margarita is asking if we can see the time evolution of flow height, flow velocity in a selected point. In general, yes, all the data is there. Can you do this as a QGIS function at the moment? No. If you go through the AvaFrame documentation, and Anna, please correct me if I'm wrong. There, Anna is our pro into the connection to ParaView. We also try to use very effective data structure to make the time evolution of flow velocity and flow thickness exportable. And usually for this kind of visualization or analysis, we use ParaView, or you can use the raw data itself. At the moment in QGIS, you cannot get a time evolution at a certain point, but the data is there and it would be certainly possible.
Then one note about the operating systems, because that came up as well. So yes, it is available on all operating systems. So we have it running on Linux, we have it running on Windows, and we also, because Matthias brought it up, we also have it running on Mac OS. Mac OS requires a bit more fiddling, but it is possible to run there as well. So we got it running. The main ones we tested are Linux and are Windows. You should know. Then there was a question regarding whether you can run both the operational mode as well as the development setting on the same machine. Yes, this is possible. You can either do this via virtual environments using Conda or something like this, but it is absolutely possible. So I do this all the time.
Massimiliano, the question for the alpha beta model setup. Yes, this is fitted to Austrian data. To be clear, I think it is 0.974 times the beta angle minus 0.1 degrees or something. So it is kind of similar to the parameterization that is used in the original Norwegian model, but this has been adapted to Austrian data by Matthias Granik and colleagues who's also here. But in the end, it's very easy to change the parameterization. Same yields for the shallow water model, for the COM1 DFA. At the moment, we've completely on purpose did not give this option for the first operational example in QGIS, which also would not be a problem. But you can change everything in the so-called ini files. So all the parameters, and if I say all, I very much mean all. There's no parameter that you cannot control, which goes from numerical parameters to flow parameters and so on and so on. and all of this is changeable in the ini files on a text level format. At the moment, as Felix said, our main goal was not to provide a GUI that can do all of this, rather to provide the correct interfaces. If there's further questions, as we said in the beginning, you can always use the lift your hand option or continue in the chat. Also, if you have some problems with setting up the simulations, we are also eager to help you. Matthias and Anna also here, they know everything about it.
And regarding this setting up, so this is something that's not working at the moment, is this experimental setup, which is something in between using operational and the development version. This is the idea then that you can just, if you don't want to look into the code itself or something like this, you get an easy way to change setup for exactly this stuff. And as JT already said, in the ini files, there you have all the options to put in to plug in your version of the configuration. And this is also important, especially if you want to use alpha beta with a different setup. We always provide the option of using local configuration files. So if you have a local configuration that is overriding our default configuration, this means if you have a setup, you don't have to apply it every time we update it. You just have to have this local configuration and make sure that your setup is being continuously.
Felix, just because we are so fast in actually our time plan, could you just share your screen and maybe Massimiliano gives us the 2 parameters he would like to use for Italy, and we can just do another adapted parameter run.
And not that I don't have to change my Python setup over, but I can show you where it would.
Yes, maybe you can show how this would work.
Okay, hold on. Over and share my screen again.
Yes. And also, so there's different levels how you, if the question is how can you contribute, how can you make a difference or work on it, use it operationally, give your feedback. You can also jump in on the developer level if you're interested. This project is very much open for collaboration and feedback.
And we are happy to leave any bug reports. So if something doesn't work, let us know. Okay, so let's look into it. So I'm now looking at the code on GitHub itself. And in this, you find all our modules. So they are basically named after these directories. And if we look at, for example, this COM2, the alpha beta version, you click on it, and in here, it's very easy to see everything. So this is the main Python file, and then you have this ini file. This is the initialization file. And all you would need to change if you want to have something else is these parameters in here. So here you have those the values that will go into, and this now comes in again with our documentation. If you want to know exactly what's going on, which parameter is which, you can have a look at our documentation and you will see the formula that is being used right now. And you can translate this to what you see in the ini file here, where the K1, K2, and so on and so forth are being used in here. So if you want to use your own values, you can change it.
And maybe at this point, it's not only about the values, because Felix also showed. So why are we already presenting this is the general question, because it's someone could say it's not finished. Yeah, but the good thing about this project, it's never going to be finished. Yeah, so for example, Felix showed that in this application or implementation of the alpha beta model, we rely on the split point, and we, for example, use an adapted version with 4 parameters, which can easily be translated back to the original alpha beta version with 2 parameters. But anybody who would like to add or change the way of how the beta point is determined, you can exactly do this here. And there is a lot of different ways how to determine the beta point. And there's also a lot of different descriptions what the beta point actually is, in the sense of the transition point between the track and the runout area. So this would be also the possibility, not only to change a parameter, but maybe even reconsider how we determine the beta point in a profile.
Christoph has raised his hand. Christoph, please.
Hello, thanks JT and Felix for this nice work. I have a more general question about how you're handling contributions on GitHub, because some contributions may also introduce some numerical issues or content issues. So is there kind of a workflow reviewing habits you're using? Can you comment on that one, please?
Yeah. So this is a good point. Since we want to have this one operational version, this one version where we are sure that it's stable and usable, the way to contribute is that you can put code on GitHub, but not on the master branch. So you put it in a pull request so you can contribute, and then it's going to be examined by us. So we go through it. We have a test suite running for every pull request. So every pull request has to go through standard tests. This is both on a very small, low level, like just code formatting, all the way up to running avalanche tests and see whether it changes the outcome of the results significantly. If it changes it significantly, or if there are major changes which we need to consider, then of course the task then is to judge whether this is better or not. And then we can discuss about how to merge this. But before it is being merged into the master, of course, there is a review process going on and a testing process, because we want to make sure that the master or the versions that we hand out on the master are the ones that we are sure are stable and usable. We might flag certain releases as being development releases. So let's say we release at 1.3 and we know this is a development release, we make it clear by either adding def or describing it in the release notes. So this is something that you should do if you update AvaFrame. Have a quick look at the release note if there is something that might consider your simulation.
And I guess the same workflow is true for, let's call it the inner circle. So
yeah,
the developing.
Yeah, if you look at what is being done, I mean, let me share my screen real quick. You can completely follow what we are doing. If you look on GitHub, and go back when this is the normal Git process, you can see those pull requests and you can see for every step that we did what we added. You can completely follow what was being done. The way we do it is then that we summarize what we did for each and every of the releases. So if you look at the releases here real quick and choose one lower down, for example, the version 1.0, because it was a big step, and we tried to summarize everything that happens in there. So if you see the code that is interesting to you and you see some changes in there, then you might have to have a look at it, what is being done.
Cool, thanks.
Maybe to add at this point, because Corbinian asked about could he do different parameter setups for alpha beta, but same yields for the common DFA in the same installation. Yes, for sure. You can do, so what kind of modules do you? So you can do pretty much as many as you want. And there's 2 points that maybe relate to these questions. One point is reproducibility. So one of the major goals of the whole AvaFrame is reproducibility, so that we can reproduce whatever simulation we ever did. And this is really how it should be. There's a hash, which Felix could maybe explain more if we need technical details, but like you have an identifier that you can reproduce which version of the code was used to reproduce this simulation, and also on which kind of parameters it was based. And you can not only use different inis to use different parameters, and this is again Anna that could help you more on this. You can even use probabilistic assessments. So even run like big sets of parameter variations and look at the results. We can't show everything today, but this you would find in the documentation and in the modules that already exist.
And to add to this, Corbinian, you can't do it from QGIS. You would have to go through the development installation at the moment.
So we have like 10 minutes left. Whoever wants can also stay longer. We're gonna hang around a little bit longer. If you have more questions or you wanna ask something on your microphone, also feel free. We still have quite some time to do this. Yeah, as said before, there's many different modules already. For example, also, if you have your own computational core, let's say it's Trend 2D, OpenFOAM, Garris, RAMS, whatsoever, we also invite you to use modules for pre or post processing. You don't need to use the computational cores. So we always tend to focus in presentations or something on computational cores, which do some of the hard work, but the whole environment of pre and post processing is also a lot. Felix, can you maybe show us, for example, the test DEMs that we use and the data that we use, which is also out there. So there's some test cases that you use on generic topographies. There's test cases on real topographies. There is post-processing modules that you kind of saw in between already. So the modules, maybe we can shortly show the pre and post-processing and the different kind of modules that we have.
So for the testing, we provide, first of all, a few tests that are trying to be as analytically as possible. These are the rotational symmetry, damp break problem, similarity solutions, but we also provide DEMs and release areas which we use for model validation. So this ranges from generating bowls or flat planes, inclined planes, and so on, all the way down to, for example, helix stuff. Very theoretical, even more theoretical stuff like the pyramid, but also real-world test cases. So the AvaILL is the one that you were, that is in the example data, but we also have 5 more, and they usually contain 1 or 2 release areas and entrainment areas as well. And all this data you can find in our repository. So if you head over GitHub and look into the code and then AvaFrame, you will find a folder called data. And in this data, we have all the inputs for these avalanches. And the way we apply it, and this is something, this comes from the question that Christoph had earlier. If you look at the example, so every time we bring out something, we release something, we go through this process by running through all these simulations, and we always compare a reference to the simulation and look at reference images. So these are pictures that you will see, can see quite often, in which we put 2 simulations on top of each other. So we have the benchmark that we want to hit and the simulations that we are doing at the moment, and then we look at differences and try to figure out whether there are any differences that are too big. And sometimes if you do something like this, of course, you won't be always able to explain everything why it's happening, but sometimes you decide, okay, this is fine, we can accept this level of difference. And this testing is also done with the help of a module. And in here, if you want to run it for your own module, you will find the introduction of how to do it. And we usually provide example scripts on doing these things. And then another point, which I might add about extracting information from the result files themselves, is that what we try to do is that if there's a good tool already available in QGIS, we try not to replicate that one. For example, if you say you want to extract values for the maximum flow depth at different points in a shapefile, there are good tools in QGIS available which you can use to do exactly this. So this is a bit of a distinction where we don't try to do work twice, which is where tools already exist.
That was a very, very important point, and I think we come soon to the end. Felix just said it, we try to not only provide reproducible results, the goal is also to reuse and recycle, in the sense of, in this small community of avalanche simulators around the world. So maybe not everybody has to write the script again and again to create artificial topography that looks like a pyramid. This is the way that you can contribute. You can also add, or if you have your most favorite test case in France, I would say mine would be Tacona, or like from Italy, that you would like to add and like to see as a test case in AvaFrame. This is also ways to contribute. Where do you find all the information? At the moment, certainly the homepage is the best. The documentation is growing and continuously changing and getting bigger and better. So this is where you find information. And for sure, we are also currently working on putting this into some peer-reviewed papers, which is current work. One of the first ones now out is the FlowPy paper, which is not 100% directly connected, because it's an other computational module that at the moment gets the full-on connection into the AvaFrame framework. It's a computational module for, let's say, similar, so it's a data-based model similar to the alpha beta model that operates in three-dimensional terrain. Could also be interesting. And there's a current GMD paper on this. If you want to get into contact, maybe Felix, share, if you can share your screen again. You can just write us emails. You can come to the workshop. You can also, what we usually use in the team, and which is also growing with some students that use it, is our communication channel on Matrix, which is a very simple chat client, makes it easy to communicate and set up work. So you'll find all the information on the webpage, and here you see what we are currently talking about while we're having the webinar.
Yeah, you will end up in this public room if you follow the instructions that we have on our contact. And once you're in the public room, just message us or say you're here, and we put you in the correct rooms that you need to be in.
So I would say we made 1 hour full right now. Whoever wants to, feel free to stay and have a chat and ask something if you want to ask more. If you want to contact us later, contact us later. If you want to connect on any of the 3 levels to AvaFrame, feel free to do so. And this will be my last question. So in the beginning, we asked you what your background is. And now, after having a 1 hour intro into the whole project, what do you think you would most likely like to use AvaFrame for? Operational, so are you going to do hazard maps and use it for your engineering background? Would you like to maybe go into research and do a little bit of development and maybe implement your own model? Would you like to use it to teach some students, or you have very good other ideas? I see there's a lot of other ideas for future use, which I would be very interested in what other means. You can put this in the chat if you want to. And I'm gonna share the results with you now so you can see your answers, which is most of the people are very much interested in operational use. Some would like to have the educational use. And yeah, I see a slight shift towards development, and I'm very interested in what other uses, which would be cool if you put it in chat. At this point, I would very much like to thank Felix for organizing the whole thing today, and Anna and Matthias for their contributions and their hard work on the project, and all of you for coming and sharing this hour with us. And yeah, feel free to stay, ask questions. Thank you.